I'm gonna explain about section 1. Section 1 contains AC high voltage measurement diagram. It started with a measuring capacitor and then it connects to the secondary capacitor. It connects by using a coaxial cable 50 ohm 40 cm. The coaxial cable have 4 layers. First layer is outer jacket, and then the next layer contain a metallic shield, and then next layer contain dielectric insulator. Finally, the last layer is a center conductor. From the secondary capacitor is connected to the B and C T junction. The purpose of the T junction is to make it parallel for the frequency with the picoscope. And then for the schematic diagram, it started with the transformer which connect to the measuring capacitor. And then for the measuring capacitor, it connect to the secondary unit. In secondary unit have a 90 capacitor connected in parallel, and then it connect to the spark gap. From the spark gap, it connect to the BNCT junction, and by using a coaxial cable 50 ohm to the VM, and then connect to the picoscope. For the safety for this lab, the breader copper need to connect properly to this equipment. First is a frequency converter FC, and then for pedestal. Third is secondary unit. And then to make sure the length of the cable must fit with the layout to avoid any accident or injury. And then always make sure the laboratory are clean. After that, put all the equipment in the right place. Finally, make sure the cage are closed when doing injection. Thank you.
Okay, for the second section, we are required to present clearly the feature and the function of kit control 4.0 section as follow. The first one is source control, the second one is primary side of the transformer progress. The third one is system monitoring of secondary side of the transformer with 8 slot, and the fourth part is alarm system. Okay, for the source control, the calibration of the AC output voltage are in one stage. We have to set up the setting according to component we are using in the experiment. Okay, based on this table, it shows all the information by referring the element that we are used. The voltage that we use is 100 kV. The main capacitor is 100 picofarad, and the serial number is 1508228. And for secondary capacitor, we use 2 microfarad, and for the serial number is 22341076004. Actually, the serial number is must tally with the equipment with the setup in the computer. And for the serial number ratio, for this serial number, the divider ratio is about 19651.1. Okay, for primary side of the transformer, actually primary side of the transformer is used to show source of current and voltage, and the other one is to show the background noise of this experiment. Okay, for the system monitoring, actually there are 8 slots in a system monitoring. All 8 slots represent each of the parameter in the kit control. Kit control is the customer setup for channel 1 and channel 2, which also represent the parameter of VM1 and VM2. This one is AC channel, and from VM3 to VM6 is used for DC. Okay, for the acquisition sample, which also represent number of sampling, it is set to in the range of 0 to 100k sample. This means that for a period, it has 100k sample or point or discrete. The higher sampling ratio, so the better shape of graph better. So the table below you can see for VM1 RMS and RMS1, for VM2 peak and square root 2. So VM3, for VM3 measure 3, VM4 measure 4, VM5 measure 5, and VM6 measure 6. Okay, and finally about the alarm system. Actually, the alarm system is in a red to indicate that it is prohibited to do any injection. In order to clear the red light, we first have to click on the red button alarm on the picoscope and push the reset button. Thus, the alarm will turn green, which specify that it is in a good condition to do the testing. However, the alarm will turn red whenever there is an opening of the control room. So actually the control room have interlock at the top of the door. So wherever someone suddenly enter the testing room during testing, the alarm will pop up as the indicator will show at the computer, red signal for alarm. Okay, I think that's all from me for this section 2. Thank you.
Assalamualaikum. Hi, I'm Auni and I'll be proceeding with section 3. Briefly, in this section is about calculating the data. We have tabulated the data with values of references that is obtained from kit control and the values of display that we obtain from the picoscope. However, we can see that there is a difference between the values, even though the percentage of output voltage are similar. There are a couple of differences that affected the error in the value, which are the coupling setting. We have set AC for the setting. AC as a coupling means that it will filter out all of the DC components. It will switching in a high pass filter on the channel input signal. Sensitivity of the range also contributes to the increment of error. We have set the value to a certain level where it makes the sensitivity more accurate. Last but not least, the noise also are affecting the difference value of display and reference. And one of the example of the noise is the noise that comes from the power supply. As conclusion, we can conclude that the picoscope are one of the convenient tools that measure high voltage. They have a lot of features and most importantly assuring our safety. Thank you.